Welcome to lecture 34, which is on data collection with the airborne LiDAR system. In previous two lectures, you have learned that how ground-based LiDAR systems and mobile platform-based LiDAR systems are useful for several applications. So, in this lecture, now we are mounting the LiDAR systems on some aerial platform and collecting the data for a large area, because in many of these civil engineering projects and other projects, we have to cover a very large area and collect the data. So let's begin with this lecture. When we are collecting the data for a large area and we have to analyze that, let us say the entire watershed or maybe the entire township, or if there is a forest fire and we have to collect the data for a large area of the forested region. So here neither the terrestrial laser scanner or nor the mobile based laser scanner would work. So we have to select some other method, some other way of collecting the data for such a large area. So we are mounting this LiDAR based system now on the aerial platform, so that the aircraft or maybe the drone system can fly to the area quickly and collect the data for that particular area using the same principle of laser beam technology, and we can use this data for analysis purpose. So here what is happening is that the data is collected at a speed, greater speed for a large area, but from a greater height. So the difference between the two is that terrestrial laser scanner and mobile based laser scanner, more or less they are collecting the data of the facade, of the elevation of the structures, because they are more or less in the horizontal direction scanning the objects. But when you are mounting some sensor in the airborne platform, the sensor will look downward. So when it is looking downward, it will cover the plan of the region. So more or less we will see from the top the plan of the different objects. For example, the building will see the area of the rooftop of the building and not the height of the building. So that is the difference. We are collecting a very large area in a shortest possible time, but we are not getting the detailed elevation data, but we are getting the plan data for that. So if we have to create a accurate 3D model, then best way would be that we combine the data from airborne laser scanner, terrestrial laser scanner or the mobile, and then we create a better 3D model, because the plan will come from the airborne and the elevation would come in a much better way from our terrestrial laser scanner or the mobile laser scanner. So if we look at this airborne LiDAR technology, it was developed long back. It's not a new technology. In 1960 this was developed, but at that time this technology was not used for mapping purpose. So because this technology was based on the laser pulse, it will send a large number of laser pulses to the ground, and we can see the dots here. The purple dots are those points where the laser beam is striking, and the pulse will return back and the information would be generated in terms of the X, Y and Z. So LiDAR data will again provide us here very accurate coordinate systems which we can use for mapping, measurement and creating the 3D model. Now when we are mounting this particular system, airborne LiDAR systems, on some airborne platform, so we have a GPS device also, so that we can get the coordinates also we have to take care of. So we have inertial measurement unit which is called IMU, and which will take care of the pitch, roll and yaw movement of the aircraft. So we have to ensure that the aircraft is moving in the desired direction at a desired height. So there should not be any rotation in all the three axes about the of the platform. the airborne platform. So the airborne LiDAR system is mounted here, the sensor is mounted at the bottom, and it will now scan the entire earth surface. So it will scan the entire earth surface and will give very accurate real world coordinate system because of the GPS. You can georeference that particular data. So this device, which is actually scanning the very large part of the earth surface, it's carrying a very high frequency scanner. Very high frequency scanner, pulse of beams will be sent, and the GPS will be the differential kinematic GPS, because we'll get very high accurate coordinate systems, and there will be a IMU which will control actually the movement of the platform, moving platform, and we can get the data. Height accuracy will be plus minus 10 centimeter. So no technology will give us such a high resolution data except the LiDAR technology from such a high platform and in the shortest possible time, because it will cover very quickly a very large area. Now, what are the process which are involved in the data collection? So we can see that there are several steps which are listed over here. Emission of laser pulse will be emitted by the device which is mounted on this platform. It will record the backscattered signal from the object. Then the distance measurement will be carried out, measuring the phase difference or the time of flight, and then you are retrieving the position of the plane and the altitude, and then you are doing the computations part of it. So these are the steps which are involved. Now, airborne based, when you are doing the laser scanning, then there are three types of scanning patterns are possible, and these three types of scanning patterns are shown here. A zigzag kind of a scanning could be there, so it is moving in that zigzag direction and covering the whole area. It could be a parallel scanning to the flight direction. So if this is my flight direction, the scanning is always in the parallel line direction, or it could be the elliptical scanning to the flight direction. So these are shown here. So these are the three different ways and three different methods through which the scanning could be possible: zigzag, parallel, or the elliptical way, covering the whole area. If we look at the LiDAR data, and this LiDAR data basically first data which was acquired in 1999 near Pavia and its neighborhood. So this data shows third dimension, and height of the buildings, height of the structures are also shown. So not only you get the height of the ground, but you are getting the height of the different structure also, and that is very useful when you are creating digital surface model. Digital elevation model you can create from the data which you get from the terrain, so surface of the earth, but individual buildings are shown here with some height, different height. So we can estimate the height of the buildings also and maybe create a DSM. So this kind of a data is really very useful for architect and planner also, for civil engineer also, and to carry out the city planning in the area. If we have this kind of a data, the planning can be carried out in a much better way. If you look at the two-dimensional view of the data, so this is a part of the Seoul, Korea. So this is a grayscale data. So representation of those million of points in the form of the grayscale, and the left side is the color coded. So these color coded data, different colors have been used to represent the data. So if you look at the black and white grayscale map, one can very easily identify from this data the different railway tracks. One can identify the road network in the area. You know, several buildings are clearly seen, open area. So if you blow it up on your screen, computer screen, you can see much more detail. But what is important is that this you can cover a very large area. As you can see here, 29,000 hectare area was covered with 0.1 to 0.5 meter accuracy. So this is the most important thing, that by any other method, by any other technique, it is really impossible to get such a high accuracy of the data. Now we have different sensors for it, which you can mount in the aerial systems, maybe aircraft or maybe drone systems. So these are just the two examples, but there are many available in the market. One here on that side and the another is on the right side, and there are some specifications which are written. So it's working in 32 channel, for example, and there is a rotating mirror so that it can cover the whole area. Now you see the weight, 1 kg weight only. So very heavy LiDAR sensors, the drone system for example cannot carry. So we require a very light system, we require a compact system, and point density is important. So it can cover approximately 1.4 million points per second. So you have huge data, what we call as the big data at the end. So you will get the big geospatial data at the end from this kind of a scanner, because for every point the coordinate systems will be there. So similarly here, now this has a range of 80 to 100 meter, and then weight is slightly more than as compared to the previous one, and 0.5 million points per second. So depending upon our use, depending upon our application, we will like to go for the LiDARs, airborne LiDAR sensors. Better is the resolution, higher is the cost. It's very simple. So these air LiDAR sensors are manufactured by various companies which are written over here, Leica, Faro, LiDAR-Tech, Phoenix, and we can use them individually or we can integrate them with the RGB sensor. So either independently can be installed or along with the RGB sensor also they can work together. And there are companies like, for example, the Yellow Scan, where you can integrate the sensor, airborne sensor, with the RGB also. Now what is the product? Product looks like this. There is a point cloud data which you can see in the left slide here of the terrain. So when you look at the point cloud data, vegetation cover, and you can actually very well see those transmission tower also. So each and every detail, minute detail can be seen from this kind of it. So you can determine the height of the structures, and also you can determine the various, and then you can create a digital surface model. So this is a digital surface model which has been created with the help of the data which has been collected from the aerial platform, and these digital surface models are very useful whenever some planning is done on the land surface. Now what is the advantage of this LiDAR data when you are working in an air platform? Because it is sending the several pulses. So these several pulses are giving me data of the different height point, the different objects situated at different height. So let us take the case of the object or the staircase kind of a object, where the first pulse is striking to the top, the second one is to the next one, next level, and this is to the bottom level. So there are 5 pulses which strike to the objects which are situated at different height, and then they will return to the sensor at UAV, and I will get the height from the each of this, the data from each of the pulse. So this is the advantage, that if I miss one of the pulses, I will get the data from the other pulses. So the multiple return mode is very useful to me. Now once we are sending several pulses, the other advantage is that in case of a tree cover, in case of a vegetation cover, sometimes the ground is obstructed, the ground is not visible. But Here when you are sending several rays, some of the pulses will actually penetrate to the ground. So they will find some open space and they will penetrate to the ground and return from the ground and will give me the elevation of that particular point. So when we are working in a vegetated area, when we are working in the area which is obstructed by the vegetation cover, so we can not only get the height of the tree or the structure of the tree, but also will get the area of the ground feature also. So for wooded areas, for forested area, this is very much useful technology, because if we are using actually here, for example, if we are taking the picture or the images, it will obstruct. So the reliability of the data is very, very high. It can operate in the day and night time as well. So during day and during night, we can take the data, whether it is mounted on the UAV platform or it is mounted on the aircraft. So that is the biggest advantage, that this sensor are active sensors, so they can be used in the night time. But if I have to take the images also of this area, then probably I require the daylight to take the images. Now LiDAR can see under tree forest. So that is the example here, that there is a actual photograph of the ground and there is a LiDAR measurements we have been taken, and this is the actual scenario of the data. So one can see the tree structure, the height of the tree, along with that the ground is also seen. So we can get the elevation data, we do not miss anything when we are working on this kind of approach. This is an example where using this kind of a data, people have identified the hidden structures. So 60,000, for example, hidden Maya ruins were identified in Guatemala, and this was a very major archaeological breakthrough. So it was in the news that using actually this kind of a data, when you are particularly, this is the actual on the left side, you can see the actual image photograph where a lot of trees cover is there, forested area is there, and you hardly see what is below the ground. You don't get any impression of the ground or the topography. But if we take the LiDAR based data of this area, which is shown on the right side, so it shows the topographical variation, and also it will give me some impression on the ground also. So one can see some structure and some outline, some shapes, some artifacts kind of a thing. So using this data, the people have identified the hidden ruins in Guatemala, and this was really a very, very major breakthrough of the laser based technology which was used in this kind of a work. And nowadays there are many studies which have been carried out where we can find out, we can get some of the traces on the ground. Actually, if suppose the soil is disturbed, we can get some traces of that with the help of the coordinate systems, and probably we can find out if there is a buried structure under the ground also with the help of this data set. Now post processing of the data is also very, very important, because the accuracy at the end would depend upon how best we are post processing the data. So these are some of the post processed output, because the raw data which we are collecting might have certain errors. We have to remove those errors, we have to apply the corrections to the data, we have to remove some of the artificial points which have been generated while doing the scanning of the whole area. So you can, for example, this post process outputs are, you can create orthomosaics with the help of this data, you can create digital elevation model, you can or create a point based cloud model from this, or very useful application is for topographical mapping, because topographical mapping used to take a lot of time, while we have to show each and every feature on the ground, and in order to not to miss any feature on the ground, usually time taken was much more, and there was very little progress when topographical mapping was done by conventional way. But since if you have this kind of a data, then with the help of the software capabilities of the software, topographical mapping could be carried out. Also updation of the topographical map, because updation of the topographical map is also another big problem for a country like India, where uh, it's covering the huge area. So but once you collect the three-dimensional data for that huge area with the help of some airborne devices, then whatever are the new infrastructure, new roads, new railway lines, new pipeline, new buildings which have come up in the area can be very easily transferred onto the existing map. So this you can use for example, creating a 3D model. You can create 3D model, you can create contours from this data. From contours you can carry out a lot of analysis, intervisibility analysis or volumetric analysis. Also this data could be used for creating thematic maps. Suppose from the whole data set we are interested in creating a road map, we are interested in creating the railway map. So we can only pick up those features and create thematic map of our area of interest or the point of interest. For assets mapping, um, each and every asset can be mapped at such a high resolution that people have used this kind of a data for creating the asset mapping. So there are very large number of application of the post process data, which is considered to be the very accurate data. Now once you have elevation data, once you have the contour map, carry out the slope analysis. Very important in large number of projects. You know, when you are laying out a railway line or you are designing a new highway or maybe a transmission line, planning has to be carried out. Then slope is very important, how the topography is changing and which area is the steep slope. This slope analysis, people have actually, the slope have been used for landslide control and monitoring purpose. And volumetric estimation, so computation of the volume of the earthwork filling or cutting can be carried out very easily. Then disaster response system. So we have to find out, you know, which are those safer areas from the flood. So naturally the higher areas will be the safer area. So similarly we can find out which are the areas which could be used for the rescue purpose and which route could be taken up. So all that planning can be done with the help of the outputs which we are generating from our data. So we can carry out the terrain modeling, LiDAR terrain modeling. As you can see here, this is the actual data of a particular area, and there is some forested area. The dark one, the textures which you see, the forest area, and then there are some green areas, and there are some open lands which is visible to us as a white dots. So this is the terrain modeling based on the LiDAR data. So LiDAR data has been collected, and one can see that this is that a river which is giving its peculiar shape. Then there is a area without vegetation cover, and there is an area with vegetation cover. So one can actually create this kind of a digital elevation model. So this is a two-dimensional elevation model, and different shades here are indicating the different heights on the ground. Now if you want to see the height of the objects on the ground, so this is a forested area, and I am taking the example of a small area, but again this small area has 0.44 million kind of a returns are there, large number of x, y and z coordinates are there. So this green portion is all vegetated area, but if you see the gray shades and the white, they are the riverine areas where the sand is there, where there is a small river. And if I further show the detail of this, blow it up this area and show the detail area at full resolution, and now you start feeling in the area. You start feeling individual object. You can see individual tree in this particular region, and one can also see the open land. So people have identified which are the possible areas for afforestation program if afforestation has to be done, or people have carried out the study how much is the loss of the forest area with respect to the time. What are the different type of species which are present can be identified with respect to their height, with respect to the texture, and if you further blow it up, you can measure height of each and every tree. You can find out the crown, you can identify the biomass which is available. So this kind of information could be used in order to categorize the different type of forest which is available to me, and also how much is the green mass available, and if we have to plant some more trees, which are the potential areas in that. Now flood mapping, uh, you know protections measures are very important when flood is taking place in the area, and we know that water will always find out the route which is the wherever the slope is less, so it will actually immediately go to the low lying area. So you can see in the slide here that when the flood is taking place, that in all that low lying area, buildings, all the buildings are submerged, but the high areas, the areas with the higher elevation, they are safe area. So one can identify which are the safer areas, and also one can identify how much area is damaged under the flood water, which are those buildings, and how to relocate the people. Now once you are collecting the data, this data, because you can get the rooftop footprint of the roof, people have also used this data in order to carry out the uh, rooftop mapping, and also determining the potential rooftops where solar panels could be installed. Uh, it is used for the topographical mapping. You can see a pond, water pond very clearly. You can see this square land also very clearly. As I told you, volumetric estimation is done very quickly. Once you have the data in the form of the contours, then you can calculate the volume. So what are the outputs from this LiDAR based? You get the three-dimensional data of the large number of points which you are serving X, Y, and Z. The data is very dense, but it is a high resolution data, and straight away this data can be, after pre-processing, after post-processing, you can use this data directly into the GIS, because this require the X, Y, and Z coordinates. So this data could be clubbed with the other types of data like the satellite remote sensing. There are some limitations of the LiDAR data. Sometimes we have the multiple iterations data, but still sometimes we find that the accuracy may not be 100% accuracy. So what we require is a high level of expertise is required to survey and collect the data depending upon the terrain, depending upon the type of the features and the equipment and devices which we are using. Now another limitation of this is that it cannot measure the distance through heavy rain, snow and fog and water. So these are the some of the limitations we have to keep in mind when we are working with the LiDAR data. Now there are very large number of applications which are there. Uh, uh, as far as the mapping is concerned, civil engineering concerned, there are applications listed here. As far as the outside civil engineering domain is concerned, there are applications listed over there. People are using in mining, they are using in cellular network planning of the transmission line. Gaming technology, this data is used, glacier volume change, solar energy planning, in oil and gas exploration, management of the coastline area. So there are forest fire, for example, is a big problem in hilly regions. So these are some of the applications where this LiDAR based technology has found very good applications, because the kind of data and the kind of information which we can get from these devices is not possible by any other means. There are some errors which could be present in the data, and this shows that we may have single error and we may have the integrated error. That single error has been divided again into several steps. It could be our ranging error, it could be our location error. So it's because of that the error takes place, or it could be interpolation error, the algorithm error. And then measuring angle error and the time synchronized error is the another error which could be introduced in our data set. Then integrated error could be roll, pitch and yaw because of the device or the platform on which the data is collected. So all these errors could be present in the data set, and we have to uh, remove that error if it is present in the data set before it is used for a particular application. So let's summarize this lecture. Sometimes, due to very limited point density, when we are using a single beam device, the overhead view of the airborne LiDAR data, the small feature extraction can hardly be identified. So if it is a single beam technology, then some small features you can miss. So the missing small targets from airborne LiDAR data you can actually locate by repeating the process. So you can take the again collect the data, repeat the flight, or maybe slow down the flight speed. So that is another. Now airborne LiDAR data has advantages over the ground based data, as it can provide the bird's eye view of the whole area and can detect the objects like culvert, ditches, which are normally hidden by the mobile platform because of the obstruction, because of the vegetation cover. Now, if we look at the cost factor of it, now if we have to hire the system and somebody else has to collect the data for us, the fixed cost is there, but the hourly cost of airborne data collection is much higher than the ground based method. So cost wise it becomes little expensive, the cost of the data collection, but average data collection cost per square kilometer of the airborne method is less. If we try to compare the cost in terms of the area covered, then airborne method is considered to be economical as compared to the ground based method, because ground based method will cover a large area, and here the speed, because of the speed of the aircraft, you get much high area covered. Accuracy part is covered, as far you get very high accuracy when we are using the data from the terrestrial laser scanner, because you are closer to the object. Maybe that high accuracy you cannot get from the airborne, because you are now little distance away from the object. So this is all about the use of the airborne laser scanner. Thank you.